The General Principle of Relativity, in its philosophical and historical aspect, by Herbert Wildon Carr. Chapter 7. Leibniz and the Theory that Space is the Order of Coexistences. The effect of Newton's discovery of the law of gravitation was to reinstate the old theory of atoms and the void in the scientific conception of nature philosophy. Newton could offer no explanation of gravitation, but he definitely established a fact. There actually is an influence or force in masses, whatever their nature, which draws them out of their path, whatever its direction, and whatever the velocity of their movement in it, and this force is proportional to the distances of the masses. But though it restored the old concept of atoms and the void, it seemed in doing so to supply just that principle, ignorance of which had constituted the gravest defect in the ancient theory. Instead of the purely fanciful theory of the clinamen proposed ad hoc by Epicurus, we now have a principle of attraction which, however mysterious, can be formulated as an invariable law and tested by actual experiment. It lent itself to theological interpretation also, for in giving matter weight, God was endowing the creation with the principle of its order and arrangement. The success of the new physical discovery in upsetting the mechanical theory of the vortices was complete. The vortex movement is inconsistent with the gravitation phenomenon in two distinct particulars. The vortex will explain gravitation at the equator, for there the centrifugal line of force is at right angles to the axis and passes through the center. But if the revolution of the sphere round its axis is the cause of this force, then nowhere else but at the equator should the falling body be directed to the center, and also weight, if it be centripetal force, should decrease to zero at the poles. The vortex theory, therefore, is inconsistent with the fact that a body falling freely towards any point on the surface of the sphere pursues a line which, if continued, would carry it to or near the center. A second fact was also plainly inconsistent with the vortex theory, that is, the fact that the planetary orbits are ellipses and not circles. The vortex will explain circular movement, but not eccentricity. A theoretical difficulty was also pointed out in Descartes' theory of the origin of motion and the possibility of its origin and development in a plenum. Matter at rest, according to this theory, must, if movement is to be possible, be conceived as disintegrated. Being a plenum, it will consist of closely packed figures with plane surfaces, let us say cubes. Now Descartes supposed that movement set going in this plenum would cause the cubes to become spherical by gradually wearing off the angles. But how could this process start without first creating a void? The movement of the cubes cannot alter their relative position without creating void. Before the movement alters the shape of the cubes by fracturing the angles, it must cause their displacement, and the slightest displacement destroys the plenum. The new philosophy, as it was called by contemporaries, rapidly and completely superseded the old. It did not correct it or supplement it. It did not borrow and incorporate some of its principles while adding new ones of its own. The Principia Philosophiae of Newton became what the Principia Philosophiae of Descartes had been. It came to pass that Descartes died and Newton reigned in his stead. The new principle was an active force resident in masses, but measurable in its effects and capable of developing a complete celestial mechanism. Nature was a system of forces residing in masses, distributed in an infinite and absolute void. The forces manifested themselves by mutual influences, causing the masses to move and successively change their relative positions in an even-flowing absolute time. While Newton was working out the great discovery which was to give a physical system destined to supersede the apparently firmly established system of Descartes, a contemporary philosopher and rival mathematician was opposing the philosophy of Descartes on purely metaphysical grounds. Leibniz, 1649 to 1716, concentrated his criticism on Descartes' conception of substance, and in particular strove to present a rational theory of the relation of the soul to the body, of mind to matter, of God to the world. It is especially in their concepts of the relation of God to the world that the philosophical principles of Leibniz and Newton are antagonistic, and on this point Newton was most sensitive. Newton did not recognize any theological difficulty in his nature concept, such as that which seemed to make the old atomism essentially materialistic and atheistic. He could find no ground for regarding God's power over matter as limited to its disposition. God could create it or annihilate it at his pleasure. But what was God's relation to an infinite and absolute space and time? Were they not in their very nature limitations? The only alternative was to make space and time the nature of God, and Newton took refuge in the attribute of omnipresence. Wherever God is acting, he is. This was the meaning of the theory that space is God's sensorium. The theological problem, which seems to us to engage almost exclusively the philosophical speculation of the 17th century, has so changed its form in our philosophy today that we incline to regard it as an outgrown mythology. It is, however, just as vital an issue today. All that we have discarded is the anthropological concept, but in the issue between idealism and naturalism, we have kept all that was essential in the old theistic problem. The challenge of the old theology to physical and metaphysical theories was whether God was conceived in them as a possibility or as a necessity. Both Newton and Leibniz believed in God, believed not only that a supreme and infinite being exists, but that the necessity of such an existence can be deduced from the fact of the universe. But while Newton argued from what the universe is to what God's attributes must be, Leibniz argued from what God is to what the universe must be. Newton was convinced that there is a living God, but no more than Laplace, who 100 years later carried out and developed his principles, had he any need of that hypothesis. Leibniz, on the contrary, could not move one step without it. Voltaire, who spread the fame of Newton's discovery, and who, as I have tried to show, did more than anyone to secure its triumphant acceptance, pointed his advocacy by the wit and mirth-provoking satire with which he treated Leibniz. Leibniz is the Dr. Pangloss of Candide. Voltaire knew well the intellectual strength of the philosopher he satirized. When Leibniz argued against the void, that the concept of such a reality was inconsistent with the attributes of power and goodness in God, for it would imply a shortcoming or defect in creation, that it would imply room for a possibility of creation which had been unfulfilled, and would mean that the world was not the best possible, the argument was received with laughter. Today we find it difficult to think it could ever have been put forward in seriousness. Yet, a study of Leibniz's thought will show how his whole concept of the monads rests upon it. It is his principle of continuity. The world God has created is not a patchwork of stuffs, but a city of active workers. The creation is not an abiding place for souls to dwell in, or a stage whereon to display their activities. The world is souls, and only souls exist. In the perfect city, every citizen realizes his own individuality, and in so doing fulfills the higher life of the community, the compound or composite existence. To suppose a void, then, is to suppose that something essential to the perfection of the system is left unprovided for or unfulfilled. This is inconsistent with the idea of a perfect God. Voltaire's biting satire of Dr. Pangloss, preserving his philosophical conviction unshaken when overwhelmed with accumulated disasters, made Leibniz appear a kind of Don Quixote in the popular philosophy of the 18th century. It is evident enough to us that whatever force the satire may have against particular theological or even religious theories, it has absolutely none against the conception in its scientific and philosophical application. Leibniz inaugurated the most momentous movement in modern philosophy. He is the founder of modern idealism. If we divest his doctrine of the peculiar theological form in which he clothed it, we see the origin of his theory in the profound dissatisfaction with the materialist attempts to give a rational explanation of the universe. The revolution which his concept of substance marks is to some extent analogous to the revolution which Newton's discovery produced in natural philosophy. It substituted the concept of a dynamic for that of a static reality. It replaced the notion of stuff with the notion of force. The monads of Leibniz are forces, activities, just as the masses of Newton attract and repel. But there the analogy ends. No greater contrast is presented in philosophy than the divergency of these contemporary philosophers. In one instance only they appeared as rivals, and on one side at least the recriminations were bitter. This was the dispute concerning the differential calculus which each claimed to have discovered. When Leibniz published his work, he was charged with having stolen it from unpublished writings of Newton, which he was known to have seen, and Newton gave substance to the charge, which he evidently believed, in an innuendo in the preface to the Optics. Leibniz resented the charge bitterly and defended himself against it. The sad thing is that one generous word from Newton would have closed the matter, for Leibniz addressed to him a personal appeal. The letter remained unanswered. Leibniz's philosophy was a doctrine of the true atoms of nature, the mode of their activity, and the way in which they combine to form the universe. The old atomic theory stood condemned by its unsolved contradictions, and constituted therefore a continual offense against human reason. The fundamental principles of the intellect are the law of identity and the law of sufficient reason, and both are flagrantly violated in the theories of atoms and the void. Divisibility is part of the concept of extension. In declaring anything extended, we are predicating of it an infinite divisibility. To say that the atom is indivisible and impenetrable and yet extend is a self-contradiction. There are atoms, but they are not extended or parts of extension, for they are indivisible and without parts. These atoms are the monads. They are spiritual entities. They are the subjects of experience, and their activity is perception. The universe is mirrored into each monad. To this doctrine, Leibniz was led by considering the contradictions in the old concept of atoms and the void. I will quote his own account written in the last year of his life. When I was a youth, I accepted the void and the atoms, but reason saved me from the imagination which makes sport of us. Imagination limits our researches, fastens our meditation as it were with a nail, makes us think we have found the ultimate first element, the non plus ultra. We want nature to stop where our imagination reaches its limit. We want nature to be finite like our mind. But this is to fail to rise to a knowledge of the greatness and majesty of the author of nature. The minutest corpuscle is actually subdivisible to infinity, and contains a world of new creatures which would be absent from the universe if the corpuscle were the atom, that is, a body all in one piece and with no subdivisions. It is important to notice here that Leibniz conceives the monads to be in their number actually infinite, whereas the atom was conceived as in its nature finite. It is interesting to see also how this concept of the nature of the monad is connected with the rejection of the other article of the old theory, the void. I have already referred to Leibniz's argument against the void as being derogatory to the perfection of God. Here is an allusion to that argument which I quote because it connects it with his general doctrine. Leaving aside other reasons against the void and atoms, here are those I base on the perfection of God and on the principle of sufficient reason. I assume that every perfection which God could put into things without derogation to the other perfections, he has put there. Now imagine to yourself a space completely empty, Surely God could put some matter there without derogating at all from other things. It follows then that he would do so. Consequently, there is no completely empty space. All is full. The same argument proves that there is no corpuscle which is not subdivisible. Such was Leibniz's attitude to the old atomic theory. What then was his position with regard to the doctrine of Descartes? From his earliest period, his interest and his research was turned inward on the mind rather than outward on nature. The main point of the Cartesian system which exercised him was the theory of the relation of mind and body. In that relation, the irreconcilable nature of the dualism of the two substances, each distinguished by an essential and mutually exclusive attribute, is most pronounced. The logical development of Descartes' principle in the monistic philosophy of Spinoza only served to emphasize the poverty of the concept. Leibniz's train of thought was probably along some such line as this. It started with the concept of God and creation, not as an assumption introduced to explain the existence and origin of the world, but as presenting the problem of existence and origin in its most complete and definite form. Give God matter and movement, could he then, as Descartes supposed, create a world? Clearly not, for what God has created are finite individuals, active subjects, moral agents. These individual activities are the real existences, and the universe is wholly composed of them. What we have to study then is the nature of these active substances, the monads, the real atoms of nature, their relations to one another, and how they come to form a world. Take then my own existence. I am a monad, an active center, an agent. The whole universe is mirrored into that center, focused there, and my activity consists in perceiving. The whole universe consists of my perceptions, but only an infinitesimal portion of these are clear and distinct perceptions. The rest are massed together, confused, obscure, and undiscerned. I am also self-conscious, aware of myself as perceiving. My monad, the monad which is in me, is apperceptive. But then I am in relation to a body. My mind is a dominant monad, and it works in complete harmony with the body. And yet this body is totally different and distinct in its nature from the mind. What is it? It consists of monads, but of inferior monads. They are infinite in number, for no principle exists which imposes a limitation on them, and yet each is individual, an active center mirroring the universe from its own point of view. In this relation of mind and body there is clearly a harmony, and it is an original harmony. It cannot have been brought about by chance, for it is of the essence of the relation. Here then, in this fact of mind and body, I have a reality which is a compound, decomposable to infinity, and yet consisting of simple elements which are individual and therefore indivisible. But this is typical of the whole universe and reveals its nature and origin. The harmony is pre-established, for it is the essence of the reality. If the universe came into existence by an act of creation, the harmony entered into the creative design and was brought into existence with the universe. Such, with its necessarily theistic form, seems to me to be the train of thought which produced in Leibniz's mind the idealist principle which he proposed to substitute for the materialistic principle, condemned on the ground first of self-contradiction and secondly of failure to satisfy the principle of sufficient reason. Though all the monads are alike in their nature, they differ in their degree. This difference of degree is wholly concerned with the ideas of the monad. Each monad is in a necessary relation to all parts of the universe, for its ideas are relative to the whole universe. And further, the monads do not differ from one another in the number of their ideas, for this number is infinite. They differ only in the degree of clearness which their ideas possess. Accordingly, Leibniz supposes a hierarchy of the monads based on the clearness or obscurity of their ideas, that is, the perceptions in which their activity wholly consists. there are three classes of created monads. 1. Simple monads, the elements of matter which have no clear thought. 2. The souls of animals which have some clear but not distinct ideas. 3. Finite minds which have confused and also some clear and distinct ideas. The supreme or uncreated monad, God, has only adequate ideas. The meaning is that, taking my own mind, for example, as the monad, the whole universe consists in its perceptions. There is no passing beyond perception, or, as Leibniz said, there are no windows by means of which anything can come in or pass out. Each mind contains the universe. But whereas I have certain clear ideas and certain distinct ideas, the great mass of my perceptions outside these are a confused, obscure, blended heap. Just as, to take one of his illustrations, the sound of the waves on the seashore consists of an infinite number of small sounds which are not heard by me as each clear and distinct, but in the blur of one agglomerated, undifferentiated mass. There are degrees, therefore, of confusion and obscurity, ranging from its upper limit in the absolute adequacy of the perceptions of God, all of whose ideas are clear and distinct, and its lower limit in the indefinite, possibly complete, confusion of perceptions in the simplest monad. The difference between Newton and Leibniz as to the nature of the elements of matter is brought out with clear decision by Voltaire. The opinion of Newton is perhaps as modest as human opinion can be. It is limited to believing that the elements of matter are material, that is, there is an extended and impenetrable existing thing into the inner nature of which we enter. God can divide it to infinity, or he can annihilate it. He has not done so, and he preserves its extended and indivisible parts as the basis of all the products of the universe. Perhaps, on the other hand, no bolder theory than that of Leibniz has ever been put forward. Setting out from the principle of sufficient reason, he tries to penetrate even into the deepest origins and into the inexplicable nature of the elements. Each body, he says, is composed of extended parts, but of what are these extended parts composed? They are actually divisible and divided to infinity. Therefore, you can never find anything which is not extension. Now, to say that extension is the sufficient reason of extension is simply to argue in a circle and affirm nothing at all. The grounds or cause of extended beings must be in non-extended beings, that is, in simple beings or monads. Matter is therefore an assemblage of simple beings. If I have succeeded in making the doctrine of the monads understood, it will be seen that it is quite as inconsistent with the concept of absolute space or void as it is with the concept that extension is the essence of material substance. The monads being non-extensive but all-inclusive activities, their relations, if we describe them as an assemblage, cannot be juxtapositions in a space external to them and indifferent to them. The universe mirrored into each active center is not a particular part of some vast expanse conceived as a container. Space, therefore, is a reality which must fall within the universe as the monad perceives it mirrored, and it cannot fall outside the monad, even were the concept of outside consistent with the affirmation of the monad. For Leibniz, therefore, space is neither a clear nor a distinct idea, and consequently space does not exist for God. It belongs to our confused and obscure perception, and in fact denotes the obscurity and confusion which is inherent in our view of the universe. It is the mode in which we present to our mind the infinite residue of indistinct perceptions, which lie behind our clear and distinct ideas. Space, therefore, is not a thing, not something which is, it is an order. In this respect, it holds precisely the same rank as time. Space is the order of coexistences, time the order of successions. Neither is a reality. Both are names for the confused blur of perceptions against which, as against a background, our clear and distinct ideas stand out. There is then a complete contrast between the two conceptions, the idealist universe of Leibniz, the materialist universe of Newton. The ultimate principle of the first is universal mind, represented as a supreme God, perfect in wisdom and infinite in power. His need of creation is not a mechanical need founded in some impulse, rational or irrational, to construct complex systems or direct simple movements to complex effects. On the contrary, it is purely a spiritual need, and creation is the bringing into existence of active subjects, so perfectly harmonized in their range, so fitted into the scheme by their degree, that no one is redundant and no possibility unrealized. God can create or annihilate the universe, but not in part, only as a whole. This was the famous concept of the best of all possible worlds, which since Voltaire has mainly served as a theme for jest. Divested of its theistic setting and studied as it should be, that is, as a metaphysical research into the nature of reality and the origin of our concept of external nature, it will answer any logical challenge. Newton's conception, on the contrary, has commended itself to the scientific mind, and it has in its presuppositions unquestionable advantages in practice. Logically and metaphysically, it is riddled with contradictions, and these appear most strikingly in its theological consequences. Newton could not be indifferent to the theistic difficulty, however little importance it may seem to have had for its successors. Hence the theory of the sensorium. It was in the last years of Leibniz's life, 1715 to 16, and in Newton's old age, that this theistic problem was discussed in the correspondence between Leibniz and Clark, one of the most valuable of the philosophical remains included in the editions of Leibniz's work. It was an unfinished correspondence, for it was interrupted by death. The occasion of this correspondence was a letter which Leibniz wrote to the Princess of Wales, afterwards Queen Caroline, wife of George II, in 1715. In it he said, "It seems that even in England natural religion has grown very weak. There are many who hold that souls are corporeal, and others who even hold that God himself is corporeal. Newton says that space is the organ which God uses in order to be conscious of things. But if God is in need of means in order to be conscious of things, it follows that these things cannot wholly depend on God. They cannot be his production. Newton and his followers have a still odder notion of God's work, for according to them, God has every now and again to wind up his work, as we wind up a watch, which would otherwise stop. God has not, it seems, had enough foresight to give his work perpetual motion. Indeed, the machine which God has made is so imperfect, according to them, that it requires polishing up every now and again by a special effort, and even needs regulating. Like a watchmaker, he reveals the defects of his watch by the number of times he has to correct and retouch it. In my view, the same force and vigor is everywhere in evidence, passing from one thing to another according to laws of nature and the perfect order pre-established. If God performs miracles, it is not because nature requires them, it is on account of grace. To judge otherwise is to entertain a very low idea of God's wisdom and power. The sting of this letter, so far as it concerns Newton, is the reference to the theory of the sensorium. The princess asked Newton to reply to it, and he commissioned his disciple Clark to defend him. It is in the correspondence which followed that Leibniz expounds with great clearness his theory of space. Real, absolute space, he declares, is the idol of some modern English. He uses the word idol, he explains, not in its theological but in its philosophical meaning, and he quotes Lord Bacon's idola tribus, idola specus. If space is a real thing, as these writers contend, then it is eternal and infinite, and they must identify it with God. Either it is God himself, or it is an attribute of God, his immensity. But then space has parts. How does that apply to God? Space for me, he says, is purely relative, as also time is. Space is an order of coexistences, as time is an order of successions. Space marks in terms of possibility an order of things which exist in the same time, so that they exist together. The manner of their existing is not in question. When we see several things together, we perceive the order in which they stand to one another. Were it otherwise, there would be no sufficient reason for the world being here, not there, now, not then. In Clarke's reply, there occurs a remarkable passage intended as reductio ad absurdum, but which sounds to us almost as an anticipation of the negative result of the Michelson-Morley experiment, which led to the first theory of relativity. If space were no more than the order of coexistent things, it would follow that should God make the whole world move in a straight line with any velocity he liked to choose, it would still be always in the same place, and when the movement ceased, nothing would sustain a shock. We have then, in the contrast between the principles of Newton and Leibniz, the distinction, in its full intensity and most emphatic expression, between a nature philosophy based on a materialistic principle and the nature philosophy based on a spiritualistic or idealistic principle. Both principles are directed to mathematical and physical researches. Both are conceived as the true principles which underlie the science of nature. Neither has stopped dead, neither has ceased to undergo development, but each has chosen a separate and a widely divergent path. So far as experimental science is concerned, the principle of Leibniz has been rejected absolutely, at times with contumely and scorn, while Newton's principle has seemed to be confirmed by the sure advance of science during the last 200 years. It is with a shock of surprise that we are receiving today a challenge to that principle, which seems to question the very foundations of the concept on which it is based. Still more strange is it that physical science itself is seeking a principle which will enable it to coordinate observations from individual centers of experience, monads, without the aid of, and recognizing the impossibility of having, absolute standards of reference independent of the observers. In effect, we are proposing in mathematical and physical science to abandon Newton's philosophy and adopt that of Leibniz.